Creating canvas animations in JavaScript is a lot like creating a stop-motion animation. You draw a shape, pause, erase the shape, and then redraw it in a new position. This may sound like a lot of steps, but JavaScript can update the position of the shape very quickly in order to create a smooth animation. In Chapter 10, we learned how to animate DOM elements. In this chapter, we'll animate our canvas drawings. Set interval. Clear rect. On the canvas. The clear rect method takes 4 arguments, which set the position and size of the rectangle to be cleared. As with fill rect, the first 2 arguments represent the x and y coordinates of the top left corner of the rectangle, and the last 2 represent the width and height. Calling ctx.clearrect 0, 0, 200, 200 erases a 200 by 200 pixel rectangle, starting at the very top left corner of the canvas. Because our canvas is exactly 200 by 200 pixels, this will clear the entire canvas. ctx.fillRect position, 0, 20, 20. Pixel square at the point position, 0. When our program starts, the square will be drawn at 0, 0. Because position starts offset to 0. Position, position, position. Get larger than 200 with the check if position 200. If it is, we reset it to 0. Set interval. Milliseconds, or about 33 times a second. This time interval is set by the second argument to set interval. At each time the supplied function is called, it clears the canvas, draws a square at position 0, and increments the variable position. As a result, the square gradually moves across the canvas. When the square reaches the end of the canvas 200 pixels to the right, its position is reset to 0. Figure 14:1 shows the first 4 steps of the animation, zoomed into the top left corner of the canvas. Figure 14:1. A. Close-up of the top left corner of the canvas for the first 4 steps of the animation. At each step, position is incremented by 1, and the square moves 1 pixel to the right. By making only 3 changes to the code in the previous section, we can create a square that grows larger instead of moving. Erase what that code would look like. var canvas equals document.getElement via canvas. var ctx equals canvas.getContext2d. var size equals 0. Set interval function. ctx.clearRect 0, 0, 200, 200. ctx.fillRect 0, 0, size, size, size. If size 200 size equals 0, 30. As you can see, we've done 2 things. First, instead of a position variable, we now have a variable named size, which will control the dimensions of the square. Second, instead of using this variable to set the square's horizontal position, we're using it to set the square's width and height with the code ctx.fillRect 0, 0, size, size. This will draw a square at the top left corner of the canvas, with the width and height both set to match size. Because size starts at 0, the square will start out invisible. The next time the function is called, size will be 1, so the square will be 1 pixel wide and tall. Each time the square is drawn, it grows a pixel wider and a pixel taller. When you run this code, you should see a square appear at the top left corner of the canvas and grow until it fills the entire canvas. Once it fills the entire canvas, that is, if size 200, The square will disappear and start growing again from the top left corner. Figure 14-2 shows a close-up of the top left corner of the canvas for the first 4 steps of this animation. Figure 14-2. In each step of this animation, size is incremented by 1 and the width and height of the square grow by 1 pixel. Now that we know how to move and grow objects on our screen, let's try something a bit more fun. Let's make a bee that flies randomly around the canvas. Well, draw our bee using a number of circles, like this. The animation will work very similarly to the moving square animation. Well, set a position, and then for every step of the animation, well, clear the canvas, draw the bee at that position, and modify the position. The difference is that to make the bee move randomly, we'll need to use more complex logic for updating the bee's position than we used for the square animation. We'll build up the code for this animation in a few sections. Circle. Bar circle. Equals function. X, Y, radius, fill circle. CTX.begin path. CTX.arcs, Y, radius, 0, math.pi. 2, false. If fill circle. CTX.fill. Else. CTX.stroke. The function takes 4 arguments x, y, radius, and fill circle. We used a similar circle function in chapter 13, but here we've added fill circle as an extra argument. When we call this function, this argument should be set to true or false, which determines whether the function draws a filled circle or just an outline. Inside the function, we use the arc method to create the circle with its center at the position x, y, and a radius of radius. After this, we check to see if the fill circle argument is true. If it is true, we fill the circle using ctx.fill. Otherwise, we outline the circle using ctx.stroke. Draw B. Draw B. Circle. To draw a bee at the coordinates specified by its x and y arguments, it looks like this. Bar draw B equals function x, y. CTX.lineWidth equals 2. CTX.strokeStyle equals black. CTX.fillStyle equals gold. Circles, y, 8, true. Circles, y, 8, false. Circles, 5, y, 11, 5, false. Circles, 5, y, 11, 5, false. Circles, 2, y, 1, 2, false. Circles, 2, y, 1, 2, false. In the first section of this code we set the line width, strokes style, and fill style properties for our drawing. We set the line width to 2 pixels and the stroke style to black. This means that our outline circles, which we'll use for the bee's body, wings, and eyes, will have thick black borders. The fill style is set to gold, which will fill the circle for our bee body with a nice yellow color. In the second section of the code we draw a series of circles to create our bee. Let's go through those one at a time. The first circle draws the bee's body using a filled circle with a center at the point x, y, and a radius of 8 pixels. Circles, y, 8, true. Because we set the fill style to gold, This circle will be filled in with yellow like so. This second circle draws a black outline around the bee's body that's the same size and in the same place as the first circle. Circles, Y, 8, false. Added to the first circle, it looks like this. Next, we use circles to draw the bee's wings. The first wing is an outline circle with its center 5 pixels. Finally, we draw the eyes. The first one is 2 pixels to the left of the center of the body and 1 pixel above, with a radius of 2 pixels. The second one is the same, except it's 2 pixels right of center. Circles. 2, Y. 1, 2, false. Circles. 2, Y. 1, 2, false. Together, these circles create a bee, with its body centered around the x, y coordinate passed into the drawBee function. Update. Appear to buzz around the canvas. The update function takes a single coordinate. We update the z and y coordinates one at a time so that the bee will move randomly left and right and up and down. The update function looks like this. Var update equals function coordinate var offset equals math.random 4 to 2 coordinate equals offset. If coordinate 200 coordinate equals 200. If coordinate equals 0, return coordinate. Changing the coordinate with an offset value int, we create a variable called offset, which will determine how much to change the current coordinate. We generate the offset value by calculating math.random 4 to 2. This will give us a random number between 2 and 2. Here's how calling math.random on its own gives us a random number between 0 and 1, so math.random 4 produces a random number between 0 and 4. Then we subtract 2 to get a random number between 2 and 2. And we use coordinate equals offset to modify our coordinate with this offset number. If offset is a positive number, coordinate will increase, and if it's a negative number, coordinate will decrease. For example, if coordinate is set to 100 and offset is 1, then after we run the line int, coordinate will be 101. However, if coordinate is 100 and offset is -1, this would change coordinate to 99. Checking if the bee reaches the edge at end, we prevent the bee from leaving the canvas by making sure coordinate never increases above 200 or shrinks below 0. If coordinate gets bigger than 200, we set it back to 200. And if it goes below 0, we reset it to 0. Y equals updating. Circle. drawBee. Update. Buzzing bee. Var canvas. Equals. Document. Get element bid. Canvas. Var ctx equals canvas.get context. 2D. Var x equals 100. Var y equals 100. Set interval. Function. ctx.clearRect 0, 0, 200, 200. drawBees, y. X equals update x. Y equals updating. ctx. Stroke rect. 0, 0, 200, 200. 30. As usual, we start with the var canvas and var ctx lines to get the drawing context. Next, we create the variables x and y and set both to 100. This sets the B's starting position at the point 100, 100, which puts it in the middle of the canvas, as shown in figure 14-3. Next we call setInterval, passing a function to call every 30 milliseconds. Inside this function, the first thing we do is call clearRect to clear the canvas. Next, we draw the B at the point x, y. The first time the function is called, the B is drawn at the point 100, 100, as you can see in figure 14-3, and each time the function is called after that, it will draw the B at a new updated x, y position. Next we update the x and y values starting at t. The update function takes a number, adds a random number between 2 and 2 to it, and returns that updated number as the code x equals update x basically means change x by a small, random amount. Figure 14-3. The B drawn at the point 100, 100. Finally, we call strokeRect to draw a line around the edge of the canvas. This makes it easier for us to see when the B is getting close to it. Without the border, the edge of the canvas is invisible. When you run this code, you should see the yellow B randomly buzz around the canvas. Figure 14-4 shows a few frames from our animation. Figure 14-4. The random B animation. Draw. Ball. Up.